one endpoint compulsorily, then only it is called as a ray. So here I am writing false, isn't it? False. Why? Why? Because a ray is having endpoint. Here he said it has no endpoint, so it is false. Next, coming to second question, line we represent like this. So here a line AB is same as BA. If I take here a line AB, if I go in direction A to B, or I am coming opposite direction of B to A, then the line will be same. There is no change in the line, isn't it? Why? Because it is indefinitely moving on. So because of that reason, A to B and B to A, the length of this line will be same, isn't it? So therefore it is true. Now coming to the point, third one, a ray AB. So this is the representation of ray. So a ray AB is same as BA, is it? So let us do one example here so that you can understand it clearly. Okay, so here the ray is starting from A and it is moving towards B, and in second case it is starting from B and moving towards A. Are they both conditions same? No, they both are not same. Here you are moving from school to your house, and here from house to your school, like this. It is just an example. Okay, so starting point here is A and here the starting point will be B. So therefore they both are not same, isn't it? So a ray A to B is same as B to A. Is it correct? No, it is not correct. Why? The starting point is here is A and here the starting point will be B. Therefore it is false. It is not possible. Next, coming to fourth one, a line has a definite length. Definite. What is definite and what is indefinite? Definite can be measured. What is the definite length? Definite. The length can be measured. We can measure the length by using scale. Okay. Length can be measured. Okay. Length can be measured. Okay. Length can be measured. It is a finite value. Finite value. It means that it is having a value. We can find the value. But in indefinite, the length we can measure, but actual length we can't say. Actual length we can't say. Okay, indefinite means it is moving on. It won't be having a finite value. So indefinite do not have value. It is continuously going on, and definite can be measured. It is having some value which can be calculated. So here, what? Line has a definite value? Yes or no? No, a line do not have definite value. Why? Because we can't measure the line. We have did examples in our previous class. It is going on. We can't measure. Okay, for measuring that, we have to cut that line. We have to take two endpoints and we have to convert that into line segment depending upon our requirement, isn't it? So therefore, it is the line do not have definite length. It is having finite length. Therefore, it is also false. Now, coming to fifth question, a plane has length and breadth but not thickness. What is a plane? It is just a closed figure by using some lines. What? A plane has length and breadth but no thickness. If I take a rectangle here, it is a rectangular plane. What is a plane? It is a simple closed figure. It is covering some area. Okay, so here this is the length and this is the breadth. So for this plane we don't have any thickness. Okay, we don't have any thickness. So therefore the plane has length and breadth but no thickness. Yes, the plane has length and breadth but we don't have thickness for the plane. It is very, very less. So therefore it is true. Okay, therefore it is true. Now coming to sixth one, two distinct points always determine a unique line. Always determine a unique line. Okay, two distinct points always determine a unique line. Is it true? Is it true or false? So see here, this is a line. This is a line. So here we are having two distinct points. Distinct points. So here we have two distinct points, that is A and B. Okay, touching points, distinct points. So here we are having two distinct points. So now it will become unique line, isn't it? Unique line. What is this unique line? It will become line segment, isn't it? It is little bit different when we take like this and when we take 2 points and we will be taking that as any alphabetic, representing that with any alphabet, then it will become unique line, isn't it? So uniqueness will be there. So it is true. Next, then you have to make a curve, isn't it? Then it won't be a line. This is called as curve. Next one, two intersecting lines cannot both be parallel to the same lines. If I am having intersecting lines, now how we will say this? These are intersecting lines. If I take like this, then they will become parallel. So at a time they won't be both. Either they will be intersecting or they will be parallel. Okay, in first case either they will be intersecting or they will be parallel. They can't act as both the terms. If I want to make this parallel to intersecting, then I have to turn this. Then they won't be called as parallel. They will be calling that as intersecting lines, isn't it? So absolutely true. So here two intersecting lines cannot be both parallel to the same line. They can't be both intersecting and parallel. They will be either intersecting or parallel. So therefore it is true, isn't it? I think you have understood this. Okay, first one, the ray has no endpoint. No, it will be having endpoint. Therefore it is false. Second one, line AB is the same as line BA. Yes, absolutely. Why? Because AB is also infinite and BA is also infinite. A ray AB is the same as BA. No, absolutely not. Why? Because here starting point is A and here starting point will be B. So they both are not starting at one common point. Therefore, no. A line has a definite length. No, it will be having indefinite length. A plane has a length, breadth, but no thickness. Yes, absolutely. The plane will be having length, breadth, but no thickness. Two distinct points always determine a unique line, isn't it? Two distinct points on a line, then they will be forming a unique line. So therefore true, two lines may intersect it in 2 points. No, they will intersect at only one common point. That point is called as point of contact, as I have written here, as we have discussed in previous class. Now, two intersecting lines cannot both be parallel to the same line. Okay, yes, if they are intersecting, they won't be parallel, isn't it? They are intersecting, they won't be parallel. Okay, so these are the things what we have discussed in this class. So now, again we are having some examples in our textbook. Okay, let me tell you. Fourth bit in exercise 4.1. So in exercise 4.1, we are having fourth bit, I think. Yes, we are having fourth bit. So what he have given here, what is the angle between two hands of the clock when the time in the circle is, first one 9 o'clock, second one is 6 o'clock, and about third one is 7 p.m. Two hands of the clock. Okay, so here what we need to do, we have to find the angle between two hands of the clock when the time in the clock is first 9 o'clock, second 6 o'clock, and third one is 7 p.m. Okay, so now let me do a problem. I have given example yesterday only. Now one more time I am explaining you. Listen carefully. So what we have to do, first one, given time in clock as 9 o'clock. Okay, as 9 o'clock. So here I am drawing the diagram. Then what we need to do? We need to find angle between two hands of the clock. Two hands of the clock here. So what we need to do? We need to find the angle between two hands of the clock. So I will draw the diagram so that you can understand it clearly. So here we are having one clock, circular clock. So I am dividing this into 12 parts. Okay, so this is 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Now the time is exactly 9 o'clock, isn't it? So shorter hand will be on 9, that is hour's hand will be on 9 and minutes hand will be on 12. Okay, he didn't give anything about seconds, so we are neglecting the seconds hand. So we are taking this, okay, sharply in this clock. The sharp time is